All right, this is chapter 13. We're on page 4 of 10. This would be night vision. Night vision. Diet and general physical health have an impact on how well a person can see in the dark. Deficiencies in vitamin A and C have shown to reduce night acuity. Other factors such as carbon monoxide poisoning, smoking, alcohol, and certain drugs can greatly decrease night vision. Lack of oxygen can also decrease night vision, as the eye requires more oxygen per weight than any other body part. Night scanning. Good night visual activity is needed for collision avoidance. Night scanning, like day scanning, uses a series of short, regular spaced eye movements in 10-degree sectors. Unlike day scanning, however, off-center viewing is used to focus objects on the rods rather than the foveal blind spot, figure 13-4. When looking at an object, avoid staring at it too long. If staring at an object without moving the eyes, the retina becomes accustomed to the light intensity and the images begins to fade. To keep it clearly visible, new areas in the retina must be exposed to the image. Small circular eye movements help eliminate the fading. Also, move the eyes more slowly from sector to sector than during the day to prevent blurring. So there was your figure 13-4. Which says, observer, once a target is detected in the peripheral field of dark adaptive vision, air crews maintain continual surveillance by using the off-center vision technique. They look 10 degrees above, below, or to either side of the target, viewing it no longer than 2 to 3 seconds at each position. All right. During daylight. During daylight, objects can be perceived at a great distance with good detail. At night, range is limited and detail is poor. Objects along the flight path can be more readily identified at night when pilots use the proper techniques to scan the terrain. To scan effectively, pilots look from right to left or left to right. They should begin scanning at the greatest distance at which an object can be perceived, top, and move inward toward a position of the aircraft, bottom. Yes. Figure 13-5 shows this scanning pattern. Because the light-sensitive elements of the retina are unable to perceive images that are in motion, a stop-turn motion should be used. For each stop, an area about 30 degrees wide should be scanned. This viewing angle includes an area about 250 wide at a distance of 500 meters. The duration of each stop is based on the degree of detail that is required, but no stop should last more than 2 or 3 seconds. When moving from one viewing point to the next, pilot should overlap the previous field of view by 10 degrees. This scanning technique allows greater clarity in observing the periphery. Other scanning techniques, as illustrated in figure 13-6, may be developed to fit the situation. All right. So we'll hold off there. That was page 4 and 5. That was night vision and scanning. All right. That was page 4 and 5, chapter 13.